Irodov problem number 1.66. A small body A starts sliding down from the top of a wedge whose base is equal to length L. The coefficient of friction between the body and the wedge surface is K. At what value of the angle alpha will the time of sliding be the least? What will it be equal to? Let's draw the diagram first. So there is a wedge. This base length is L, this is alpha, and there is a small body A which is sliding down. The coefficient of friction between these two surfaces is given as K. Okay? So the question is, at what value of alpha will the time of sliding be least? Okay. So let's draw the free body diagram of A. It has mass m2g, the weight due to gravity. There is normal reaction. This is the surface. Since this angle is alpha, this angle will be alpha. Okay. It is sliding down, so friction will oppose the relative motion, so friction is this way. Okay. And let's say the net acceleration is A in this direction. Okay. Now, let's frame the equations of motion. So m2g cos alpha should be equals to n, because there is no motion in the direction perpendicular to the plane. So friction, which is kinetic friction, is given by Kn, coefficient of friction, times the normal reaction, will be K m2g cos alpha. Okay. Now along the surface of the plane, m2g sin alpha is the component of m2g along this direction, minus friction force is responsible for m2's acceleration, and acceleration is A. Okay. We can substitute value of F here. So m2g sin alpha minus k m2. Why the heck did I do m2, by the way? I don't know why, but k m2g cos alpha is equals to m2a. So all the masses we can cancel out. So this becomes g sin alpha minus k cos alpha equals A. Okay. Now we can see value of A is a constant, because everything here is a constant. Okay. So for constant acceleration cases, we can use the formula S equals ut plus half at square. So S is this distance, which is L by cos alpha. Initial velocity is 0 because it starts sliding, and the remainder is half at square. So A, we can substitute this value, sin alpha minus k cos alpha t square. So now we got an expression where t is a function of alpha. Okay. We can further simplify this as, let's say, t square equals 2L by g 1 by cos alpha sin alpha minus k cos alpha. Now t square will be, so let's write here, for minimum t, we have to minimize t square. So we have to maximize the denominator. This is a constant part, so cos alpha times sin alpha minus k cos alpha should be maximum. Now let's say this is y. Now to find maximum y, we can do dy d alpha is equals to 0. So first let's do the differentiation. So that is cos alpha plus k sin alpha plus sin alpha minus k cos alpha times minus sin alpha. So minus, okay. So cos square alpha plus k sin alpha cos alpha minus sin square alpha plus k sin alpha cos alpha. So cos square alpha minus sin square alpha, we can write cos 2 alpha, and this is 2k sin alpha cos alpha, so this can be written as k sin 2 alpha. Okay. So for max y, dy d alpha should be equal to 0. So if I substitute that, k sin 2 alpha should be equals to minus cos 2 alpha, or tan 2 alpha should be equals to minus 1 by k. We can further write this as 2 tan alpha by 1 minus tan square alpha is equals to minus 1 by k, and if we simplify this, this becomes tan square alpha minus 2k tan alpha minus 1 equals 0. So tan alpha is minus b plus minus root over b square minus 4ac by 2a. So this becomes k plus minus k square plus 1. So we got two values of tan alpha. When tan alpha is k plus root over k square plus 1, then y is maximum, so that gives me minimum t. So alpha for minimum time is tan inverse k plus root over k square plus 1. Okay. So this is our answer for alpha. Now what is the minimum time? T min. We need to substitute value of alpha here. Let's do a bit of simplification here. So this can be 2L by G. If I divide numerator and denominator by cos square alpha, so this numerator becomes sec square alpha, and this will become tan alpha minus k. And sec square alpha we can write as tan square alpha plus 1 and tan alpha minus k. So T min or T min square, let's write that as 2L by G tan square alpha plus 1. Tan alpha is k plus root k square plus 1. So squaring that 1 will give me 2k square plus 2k root k square plus 1 and this one makes it 2 divided by tan alpha minus k. So that gives me root over k square plus 1. Okay. So this gives me 4L by G. This we can write as k square plus 1 plus k root k square plus 1 divided by root k square plus 1, which we can further simplify and write as 4L by G root over k square plus 1 plus k, or finally minimum value of time is 2 root over L by G times k plus root k square plus 1. Okay. So this is my value of minimum time. All right. So that's our solution.